Okay, this is going to be a video again talking about inverse functions. You'll notice that f inverse up here in the upper right. Remember that -1 exponent on a function means we're finding an inverse function. And so again, this is sort of a part 2 video, so I'm going to move kind of quickly through some of the fine-tuned details. But if we want to graph, first of all, let's go ahead and graph f of x. Let's do that in red here. We're going to have f of x in red. Again, we know it's a square root. We also know that we are shifted. If we think about some transformations here, we're shifted to the right 2 units and down 3 units. So a normal square root would start at the origin. I'm going to go right 2 units and down 3 units for my starting point. And then again, square roots typically sort of rise to the right, right? They're going to do something like that. So again, I'm going to do a little more detail than that though. Again, usually if I move over 1, I'll move up 1. Then if I move over 3 more, right, what used to be 4, square root of 4 would have been 2. So now we're 4 units to the right, but again, up 2 units. And again, I would normally have gone over to 9, right, and up to 3. But in that case, I'm going to take that same point, right, and I'm going to move it right 2 units and down 3 units. So we should be just off our graph kind of over here. So again, there's my graph for the function f of x. What I want to do over here at the right is find and graph f inverse of x. F inverse of x. So again, if you remember how to find an inverse, step 1, we're going to switch x and y. And then step 2, we want to solve for y. Well, let's take our function then. Instead of f of x, let's call that y. And so we're going to say, okay, switch x and y. I'm going to say x equals the square root of y minus 2 minus 3 on the outside there. Notice, make sure your square root ends in the right place. Then we just need to solve for y. So let's add 3 to both sides. Again, canceling that minus 3 on the right, leaving you with the square root of y minus 2. Then we're going to say, let's go ahead and square both sides, right? We want to take the square of this side, and we're going to put that in parentheses and square that other side. So we're going to say that this is x plus 3 squared. No reason to actually do the squaring. I think we're in good shape here. Square root squared becomes y minus 2. And then finally, we're going to add that 2. So it looks like we got y equals x plus 3 squared plus 2. And we would say that again, instead of y, that's f inverse of x. But again, we would be equal to x plus 3 squared plus 2. And if we wanted to go ahead and graph that, well, note to self, again, we've got a squared, so we're talking about a quadratic, and we're going to be left 3 units and up 2 units. Now that should sound pretty familiar. Notice we had gone right 2 units and down 3 units before, so we're sort of backwards of that now. I'm going to go left 3, right? My inputs and my outputs have been switched. So what happened to x before is now happening to y. What happened to y before is now happening to x. I'm going to go left 3 units and up 2 units, and that's going to be the vertex of my parabola. Now, we got to be a little bit careful because, again, if I draw that parabola, right, and again, not much detail there, but that doesn't really look like a perfect reflection, right? Every inverse graph is going to be a reflection over the line y equals x. Well, the problem is a parabola and a half a parabola, well, those aren't perfect reflections of each other. So we got a problem here. What we need to remember is the domain and range of f of x. The domain of f of x, remember, note started at 2, right, and only went to the right. So x was greater than or equal to 2. And kind of more importantly, we'll see why here in a minute, the range, y started at -3, right? And again, only rose from there. But remember, to find an inverse, we switch x and y, which means we've switched the domains and the ranges. So this range is now going to become the domain, right, of the inverse function. So x now needs to be greater than or equal to negative 3. And at the same time, the domain, right, of the old function over here just became the range. R, or the range, would be y is greater than or equal to 2. Now, why did I say that was slightly more important, right? This idea that the domain is going to be x is greater than or equal to negative 3. Well, that means that when we look at our parabola, right, our blue parabola up here, up top, I can only use x values, right, that are greater than or equal to negative 3. So I only want x values to the right of. I can't use this entire left side of the graph. I only want things that are going to the right of, right, that function. So let's do a little more detail this time. I'm only going to fill in points on my parabola to the right side of, right? So if I'm at negative 3 here, I want to go to negative 2. Negative 2 plus 3 would be 1. Squared is 1. Plus 2 is 3. So I'm getting that point right there. If I plug in negative 1, right? Negative 1 plus 3, it's going to be 2. Squared is 4. Plus 2 is 6. So 3, 4, 5, 6. Getting that point there. And notice we had gone up 1, right 1, up 1, right 3 when we were talking about f of x here, right? Well, now I'm going right 1, up 1, right 1, up 3. Again, when I'm talking about f inverse of x. And now it looks much more like, again, those points, right? Our starting point is a perfect reflection over that purple line. We get that point here, reflecting down here. And again, if we go straight through that line of reflection, again, negative 1, 6, and 6, negative 1, a perfect reflection there. So again, don't forget, when we're finding an inverse function, the idea behind it algebraically, switch x and y, solve for y. On a graph, it's a perfect reflection over that line y equals x, right? That purple line that we drew. Again, just y equals x. And lastly, something to remember, the domain and the range of the original function are going to switch places. The domain just became the range, and the range just became the domain of our new function. Again, I hope that helps you with inverse functions. If you have any questions about that, maybe watch a few more videos. Otherwise, talk to your teacher. And of course, have a great day.